Okay, this chapter we're learning about triangles, and in fact, I believe was the chapter about right triangles.
Yes.
Is that what the chapter is? Right triangles. Actually, they slide a lesson in here where we're not doing right triangles. How about that? Okay. Oh no. Yeah, it seems like they did fib a little bit, didn't they? Um, but what we're gonna do is we're gonna learn how to solve for some missing sides that it we don't that blah, blah, blah. I can't talk. That we can't like get it out.
I'm gonna
That's
go
it.
watch it
See,
tonight.
now I'm gonna get the most hits that I've ever get for this. Okay. So,
I'm not even kidding. I'm gonna go and record it. Make it like my ringtone.
all right. So we're going to do a triangle. Let's try this again. That is a knot. That is
Your video goes
not a
viral.
right triangle. I don't think that's gonna make it go viral, but if it does, more power to it. All right. So I've got a triangle here. We'll call this C. We'll call this A. We'll call this B right here. So we're going to talk about triangles that are not right triangles, and we're going to actually solve for the missing stuff. All right. Remember, with the trig functions, you can only use the trig functions on what type of triangle? On a right triangle. Okay. This kind of looks like a right triangle, doesn't it? Tell you what. Let's make this not look so much like a right triangle. Let's stretch this out a little bit. I tell you what, I'm gonna redo. You're gonna hate me for this, but yeah, we'll just make it look like that. Sorry. Then we'll call this C and A and B. Sorry. You could keep the other triangle that you have. It doesn't really make that much difference. Now let me show you this. If those are the angles that I call it. Now on this stuff that we're going to do basically two different things, two different laws that we're going to learn. Yep, law of sines and law of cosines. In fact, we're going to go opposite that the book does. I'm going to go law of cosines first, and I'll do law of sines. Yeah, let me go ahead and do that. So watch this. If this is angle C right here, the side opposite angle C, guess what side I'm going to call it? Instead of calling it AB, which kind of gets in the way using two letters, how about, since it's opposite angle C, and this is capital C, let's call this little c, all right? That's supposed to be capital, a little bit bigger, all right? So if this is angle A, what do you think the opposite side of angle A is going to be called? Side A, right, little a, lowercase a. And this is capital B, and this is going to be lowercase b. Everybody see that? Anyway, it makes it a little consistent, and it's easier to deal with for what we're going to do. What I'm going to do is this. This is not a right triangle. So if I gave you some information about this, and I asked you, to find a missing side, you wouldn't be able to do Pythagorean theorem, right? That's out the window now because you can only do Pythagorean theorem with right triangles. You can't do any of the trig function stuff because that's only with right triangles. So you need another way to do this, and this is where this comes in. This is called the law of cosines. The law of cosines. So we use this. Yeah, we'll do the law of sines in a second, but we're doing law of cosines right now. So the law of cosines is a method. It's a way that you can use to solve for missing sides if you don't have a right triangle. All right. So these are for non-right triangles. Everybody got that? Because if you had a right triangle, you could just use your trig functions to figure it out. But you can't use your trig functions on this. So let's. The best way I think. Let's show you what the actual law is, and then we'll do an example. Okay. So here it is. It starts off very, very close to the, well, it starts off exactly like the Pythagorean theorem, okay, but it doesn't finish there. So I'm going to start with c squared. C squared equals what? A squared plus b squared. All right, so that's basically half of it right there. So half of the law of cosines is the Pythagorean theorem, but they throw a little extra stuff in there. All right, it's minus, and then 2ab. Then where's the cosine come in? Well, glad you asked for that because there it is. The cosine of C. There it is. You need to memorize that. Yeah, it is great. So look, the first half of it you got to already memorize, don't you? It's the Pythagorean theorem. C squared equals a squared plus b squared. And then you just got to memorize this a little bit. Minus 2ab cosine of C. Now look what I have here. This is the only angle. This C is a capital C because you can only take the cosine of an angle anyway, right? So it has to be an angle. So it's the cosine of C. What is this C right here? Well, it's not hypotenuse because you can only have a hypotenuse if you have a right triangle. So we don't have a hypotenuse. Okay, but it is the side that's opposite this angle. All right, I didn't have to call this C. Even right here, I didn't have to call this C or this C if I wanted to. And they do this in the book, but I don't teach it like this because I think it's more confusing than anything. Don't write this down, okay? But this is what the book does. They could say this. A squared equals, what do you think? B squared plus C squared minus 2. And then BC cosine of what? The angle opposite this side. Don't write that down, all right? Because I think it's more confusing. But the book does this. So if you look in the book, you'll see that. Do you understand that? That this thing that's by itself, this is a side that's opposite that angle. All right, so the one that's by itself, sitting out here by itself, is the side that's opposite the angle that you're taking the cosine of. All right? They do this 3 different ways. They do one for C squared, one for A squared, and then, of course, what? One for B squared. Okay, I don't see any reason to do that.
Please excuse the interruption. If you could dismiss the girls' lacrosse team at this time. Thank you.
So there's the law of cosines right there. Yes, it's in the... Yep. Good. Yeah, we're on track for this week so far. It's only Tuesday, so that's good. We're on track. So there it is right there. So how in the world do you use this stuff? Well, let's see. Let's throw some numbers in for A, B, and C. Let me see what they give you here. And we'll put some angles in here as well. Yep, let's do this one right here. Tell you what, let's draw it like they do in the example. I was going to just try to use that triangle right there, but let's go ahead and just draw it like it looks in the book. So if you go back to the book and look at it, at least look kind of the same. So there's one side of the triangle looks like that. Another one kind of drop it down so it doesn't look like a right triangle. Drop it like this. There we go. All right, and we'll just put the values in here. We'll call that X. This little angle right here is 28 degrees. This side right here is 11. And this side right here is 9. And we're trying to solve for X. Yep. So if you take a look at this, this is the side we're trying to solve for, right? So what is the X in this formula right here then? I should say this. I didn't ask that question very well. This is what we're trying to solve for, right? But it's opposite the only angle that we know in this whole triangle. So it's the C, right? So the X is opposite the only angle that we know. So look, remember this thing right here has to be opposite this angle. You with me? All right. So if we were going to do this, this would be the C in our little formula. What would the 11 and the 9 be? The A and the B, right. And this angle right here would be our angle C. Does that make sense? So you don't always have to have every triangle written with an A, B, and a C, right? You could have different letters and it still works. So it's just understanding what we have. So if this is the angle that they give us, it's the only angle that they give us. So I can't figure out this one or this one, can I? Only knowing one angle. And I can't do this side. I can't say, oh, let's just do Pythagorean theorem. I can't do Pythagorean theorem. Why not? Because I don't know this is a right triangle, do I? All right, so I'm going to use the law of cosines. It works perfectly with the law of cosines. So here's how I set it up. X squared equals, and then the other two sides. It doesn't matter what order you do that, but 9 squared plus 11 squared. Now what's the rest of it? Minus what? 2, and then times AB, right? What's my AB? It's these two numbers right here, okay? So these two are always these two right here. Got it? So that's a 9 and that's an 11. And then it's always the cosine of the angle that's opposite this side, which is 28 degrees. And that's basically it. That's basically your math. Really, your math involved here is just using a calculator. All right? So let's use a calculator and solve for X. It's memorizing the formula and plugging it in. Okay, now there will be times where you might have to solve for something else. But I think for the most part, when you're using the... They may ask for the angle. They may ask for the angle. Okay, and that's a little more difficult. We'll do one right after this, though. Okay.
So, or like, what if instead of angle 28 sitting there, it was like angle 64 on where the angle's next to X?
Yeah, we would use something else if we did that. She just left. It's a good question. The reason we use this is because it fits perfect with our law of cosines, because we have the side we're trying to find opposite the angle that we know. We know the other two sides. We know the actual lengths of them, so we can plug everything in. So this just fits like a glove, just fits perfectly. If we have different information given, we may be able to use the law of cosines, but we might have to use the other one that I haven't taught yet, which is law of sines. Okay, so let's take a look. The hardest part about this is using a calculator. It's easy just to plug those numbers in, right? I mean, you have to know what numbers you're putting where, but here's how I would do this on the calculator. I think it's very important. Let's do this first. I think it's very important to use parentheses on your calculator. And where are you going to use a parentheses? I'm going to use a parentheses right here, and I'm going to use a parentheses right here. So if you have a TI-30XA, is that what it's called? TI-30XA, you're going to put parentheses right here. So let's talk through it. Who's got the 30XA? Who's got that calculator? Okay, let's talk through it, see if you get the answer, and then I'll show you how to do it on my calculator that I have up here, okay? I mean, punch it in. Oh, you got a different one, right? So what I'm going to do is this. Everybody with me, ready to punch in? 9 squared plus 11 squared minus, left parentheses, 2 times 9 times 11 times 28 cosine, right parentheses. Okay, then hit equals. And then what are you going to have to do? That's what x squared is equal to. So what do you have to do now? Square root. Take the square root. And then you should get the answer there. So I'm hoping you'll get around 5.2.
Yes.
Okay, good. All right. Did that make sense? So the 9 squared plus 11 squared minus. As soon as you hit that minus, it gives you a rather large number, right? Whatever 9 squared plus 11 squared is. And then you put a parentheses, a left parentheses, and it goes to 0 again. Then you hit 2 times 9 times 11 times 28 cosine. That's the cosine of 28. Then you hit right parentheses. What did that do? That number is everything inside that parentheses. You hit equals, and it gives you this whole thing, right? These two added, and that subtracted from this. And then you hit square root, and then it gives you that 5.2. All right. On this calculator, if I remember how to use this, you could start off with a square root if you wanted to, but I'm going to do that at the end. I kind of like to do that at the end. So 9 squared plus 11 squared minus, and we're pretty much doing stuff the same way, minus, and then parentheses, left parentheses, 2 times 9 times 11, and then cosine of 28, right? That parentheses just closed into 28, but now I need to close this parentheses in. That's that right blue one right there, so I do it twice. And then I'm going to go ahead and hit equals, and then I'm going to take the square root of that. So the square root of my answer, do you see that ANS right there? It's a second function. What that does is it applies the number to whatever you tell it to do. So I put square root of this answer, so it's going to take the square root of that number right there, and you get about 5.2. All right? That's the hardest part of that anyway. Now there are times where they give you all three sides and you need to find what the angle is. Okay, you can use the law of cosines with that. Let me see if they give an example. Yeah, they do. Yep. Since we're on law of cosines, let's do another example where you have to find the missing angle. So the math is a little bit more involved. We're actually going to do some math on that one, okay? And let's draw the triangle. Looks like that. Looks like that. And this goes to here. And this is 3, 6, and 8. And this angle is what we're trying to find. Look what they give you. They give you all three sides, don't they? They give you all three sides and they ask for a missing angle. Well, we're still going to use that law of cosine. But this time, I know what the c is. I know what that number. Which number am I going to use for the c? If this is my x, if this is the unknown angle, the angle I'm trying to solve for, yeah, this is going to be the number that's all the way to the left. Okay, it's that c squared. So let's put it in there. So it's going to be 8 squared equals a squared, or c squared equals a squared plus b squared, right? So that's the other two sides. So I've got 6 squared plus 3 squared minus 2 times AB, which are those two sides right there, 6 and 3, times the cosine. Let me scooch this over so it's not going to record. Times the cosine of what? Of x. We make it a big X because it's an angle, okay? Now, this is where it gets a little bit tougher because we got to get x by itself. It's not a matter of just plugging stuff into a calculator. Now watch, I don't want you to start doing this. Don't start putting 8 squared is 64 and 6 squared is 36 plus 9. I don't want you to start doing that stuff. I mean, you can and it can work, but I want you to do some algebra on this, and I want you to get x by itself. All right, I want you to do this algebraically. Let's do it in yellow. It shows up a little better. So we want to get this by itself. Look at this. This is a crazy looking algebra problem. How in the world do we get that by itself? Well, let's do this. First of all, let's get rid of what's being added or subtracted first. Okay? So for instance, if you had something like this, if you had 7 equals 3 plus 2x, what's the first thing you would get rid of? Subtract the 3, right? So that's exactly what I'm going to do here. I'm going to subtract the 6 squared and subtract the 3 squared, right? So let's just do that. So 8 squared is already over there. How do I get rid of this? Subtract a 6 squared. I'm just going to write it 6 squared because I'm going to wait to the very, very end, plug everything into my calculator in one shot. Okay, I'm not going to do these little tiny little steps. That'll take too long. So then I'm going to get rid of this 3 squared and I subtract a 3 squared. Follow so far? Yeah, that's not too bad. All right. So look at this. So I subtracted a 3, didn't I? And then that canceled, and I have 2x. What would you do next on this little tiny problem up here? You divide by 2, wouldn't you? Okay, you find whatever's being multiplied by your variable, and you divide by it. Well, what's being multiplied by, not just by x, but by the cosine of x? What's being the -2, the 6, and the 3? So how do I get rid of that? Divide it, right? Yeah, you got to get rid of the negative as well, right? So I'm going to divide both sides. Now you know they're going to cancel out when I divide this side, right? I don't really need to show that, do you? I think our algebra is strong enough now. I don't have to show every little step on both sides like I did up here. In Algebra 1, maybe, but not now. So watch what we're going to do. We're going to divide by a -2, a 6, and a 3. So I divide by -2 and a 6 and a 3. Right? So that gets rid of that, and that. What's all that equal to then? The cosine of x. Well, how do we get x by itself now if you have a cosine in front of it? Take the inverse of it, exactly right. And if you want to write it down, you can. If you want to get rid of this, you can just write inverse cosine of all this stuff right here. If you didn't want to write that, that's fine. Just make sure that you hit the second function cosine. Kind of like hitting the square root on that other problem, right? Make sure that you do that. So now look, this is what you're putting into your calculator. Hope that made sense. If it didn't, you can go back and look at the video. Take it step by step. So let's do it on this calculator first. What I would do, well, I tell you what. Let me talk you through it first on your TX. I always forget that. TI 30XA. Okay. Sometimes I remember, sometimes I don't. On that one, I would do all this stuff in here first. I go 8 squared minus 6 squared minus 3 squared. I don't think you have to, but I always like to put equals at this point. Put it equals, and that's that whole top. Then what would you hit? Divide, and then I would hit a parentheses. Again, I'm not really sure if you have to, but it would make me feel better if I was going to do that. So divide by, and then parentheses, -2 times 6 times 3, right parentheses. Now that just tells you what the denominator is, right? Hit equals, and it's going to give you the whole entire thing. So you get some number, right? All right, that's all right. But then what are we going to do with it? Second function, cosine, and hopefully you'll get the right answer. And you should. Yeah, they said 122, so that looks right. So x is around 122 degrees. Usually when you find an angle, they just tell you to round it to the nearest degree, not a decimal for whatever reason. They just like you to do that. So we'll just round it to the nearest degree. Does that make sense? Now, if
Part is trying to figure out to make sure you did it right in the calculator.
it's a degree one, what?
If it's like a degree one where you have to find the angle where it will always be cosine.
Well, if you're going to use law of cosines, it will. Yes, and it'll always be the second function, the inverse cosine. So let's do it on this calculator to see what it
Just
looks
a
like.
couple quick announcements. If Mr. Fairfax leadership
this.
class that meets period 8
8
could
squared
please meet in room 301
minus 6
today,
squared
that's going to be a permanent change.
minus
So Mr. Fairfax
3
leadership class to room
squared
301 for 8th period. Also, just a quick reminder,
divided
course
by
requests.
parentheses
Sheets were sent home Friday.
negative
Please
2
return them as soon as possible.
times
Thank you.
6 times 3. Let me finish this up real quick. And then that hit, right? So that's all that stuff, right? Did I do all that right? And then what I'm going to do is I'm going to hit second function. I could just put cosine of that number in there, but I'm going to do this. I'm going to hit second function cosine of what? Of that number, right? I could just punch that number in, but on this calculator I could also do what? Second function what? Answer. See that? And then it didn't work. What did I do wrong? I knew that didn't do wrong. I don't think I needed to. I must have. Oh, you know what I did? I know what I did. See how I hit the divide right here? What was it dividing? It was only dividing 9 by this stuff. Do you see that? It wasn't dividing the whole entire thing. It was going this squared minus, and then it was actually on its own kind of putting a parentheses there. So I should have put a parentheses around this whole entire top. And I don't know if I can still do that. I don't think I can. Let's try it. I won't erase this, so we'll see the difference. So let's try it a little quicker. 8 squared minus 6 squared minus 3 squared.
One other announcement.
Okay,
if
so that's the
high
only thing
school
different that I
worship
did.
team could meet in
Divided
the
by,
Pusey Center today,
and
8th
then
period.
negative
High school worship
2
team in the Pusey Center.
times
Thank you.
6 times 3 parentheses, and then hit equals. There we go. That looks better, doesn't it? See, that was the only thing different. You see what the calculator was doing here? And you have to think what how the calculator's thinking, and you have to make sure that you tell it the right way to think. And now we can hit second function cosine of my answer, and then that should give us... Oh! Oh, I put the stupid that thing. Oh, I accidentally hit something else that I wasn't supposed to. Anyway, it'll work. Will it? Oh, it cleared everything. Oh, my goodness, all that work. It'll work, I promise you. Because that's the number you saw on your calculator, right? Yeah, it'll work. I just accidentally hit a wrong button. That was dumb.
So gonna go viral.
Yes. Oh, yes. I thought you had a question. Sorry. All right, so anyway. Oh, I got the answer. I just clicked the wrong button, and I didn't feel like redoing it again. Well, it looks like we're just hitting law of cosines today, doesn't it? And I think, did I put that on the let me see what I did. No, I think I was pretty ambitious when I wrote the lesson plans, thinking that I'd be able to do both of those in one day. Normally, I take one day to do the law of cosines and then a second day to do the law of sines. There are some problems, and this is what I want you to do. There are problems where you can use the law of cosines. Everything fits perfectly. But you're going to run up against some problems where you can't use the law of cosines to solve. So if you look at it and you're like, there's no way anything fits for this law of cosines, well then guess what? You probably have to use the law of sines, which we haven't talked about today, and we don't really have time in 2 minutes to do the whole law of sines, okay? So we'll do that. We'll do the law of sines tomorrow, and but go through them and find the ones that you can actually use the law of cosines. They actually... do what you can on this, okay? Watch this. They give you a little bit of a hint. If you're going to use the law of cosines, they kind of give you a hint. There's 2 things to look at. If you have side angle side, which means if they give you a side or 2 sides and an angle that's in between, most of the time you could probably use the law of cosines. All right, that's what we did before, isn't it? All right. And then if they give you what? All three sides. That's what they did right here, isn't it? They give you all three sides. If they give you all three sides, you should be able to use the law of cosines. So that kind of helps you out a little bit. So if they give you two sides and an included angle, you'll probably be able to use the law of cosines. And if they give you all three sides, you'll be able to use the law of cosines. So look for those two things. If those two things are true, do those particular problems. All right?
Us
On that.
people aren't going to be here tomorrow.
Right.
So
So we're going to do law of sines tomorrow.
is that all you're
So
going to do?
What's the homework for tomorrow?
it's going to be the same homework, just do the problems that you didn't do law of cosines
Or
with.
is it gonna be 12 to
this all on at the same time.
Yeah, 12 to 28 is your homework, okay? It's page 587. All right, so that's your homework. So I don't know like how many of these are the law. I didn't go through and figure out each one and which ones are law of cosines, which ones are law of sines. But
First 9 are definitely laws.
okay, so yeah, there's probably a whole bunch of them.
The first ones are probably the signs, and then the second one.
Yeah, because remember the book teaches the law of sines first, then law of cosines second. All right,
Really, we only have to do 22, 28.
do whatever works right here.